Good morning, good afternoon, good evening, everyone, and welcome to today's Ask Me Anything webinar, and it's entitled Wireshark Packets Never Lie, or Do They? So we're thrilled to have you all here, whether you're joining us from across the street, as obviously we've just discovered, or halfway around the world, or above the Arctic Circle. We're in for an exciting session as we dive into some of the latest innovations and challenges in the wireless technology space. Today, we are incredibly fortunate to have a presenter who is both an expert and a visionary in the field. So Phil Morgan here has spent over 2 decades helping to shape the future of wireless technology, working with organizations worldwide, helping to implement cutting-edge solutions that drive efficiency and growth. From wireless networking to cybersecurity, Phil has a deep understanding of the technologies that are transforming industries and is here to share some valuable insights with us. As I mentioned, during today's session, we'll be exploring Wireshark. So be ready to take notes and ask plenty of questions during the Q&A segment. Upon entry, you will be muted. And also, if there's any kind of unexpected background noise that's associated with your name, because it kind of flashes up, we will mute you. And then what we will do is, because this session is being recorded, we will upload it to our YouTube channel in the next few days. So without further ado, please join me in welcoming Phil Morgan, who will be taking us through today's exciting discussion. So Phil, it's over to you. Take it away.
Thank you, Ree. That was an awesome introduction. Thank you very much. All right, let's do this. So, good day. We agreed earlier that good day covers wherever you are in the world. Someone's going to say, well, it's nighttime here. Okay. A good day to everybody. We're going to talk about some tricks and traps with Wireshark that I've come across over the years. So, quick notice. Obviously, we've tried our best to make this as accurate as possible. So, please don't rush out and do something because we discuss it here. Just be careful and plan what you're doing, okay? A little bit about us, and I'm going to just leave this up. Obviously, if you need more, you can take a screenshot or you can watch it on YouTube. Our intention, as Ree said, is to upload this to YouTube so you can watch this later. And also here, this is a bit about me, blah, blah, blah. Then there's my contact details, a link to some of my blogs that I'm updating as we go along. The Wizard of Wi-Fi one kind of links to my Wi-Fi 6E, my Wi-Fi 7, and my security blog. And then this one at the top here is NC Experts blog, where I and others write interesting articles about Wi-Fi training, security, and so on. So I would definitely take a look at those. Why are we here then? What's the point of this? Someone asked a question recently in one of the forums, and I thought it would be a really good idea if we could discuss and if people could ask questions openly, and maybe we could have an information session on them. So that was the purpose of the AMA, Ask Me Anything. Our goal is that NC Expert, of course, is sponsoring this. And so our experts and others can come along and do a session about something that a lot of people want to learn more about. And we thought we'd kick it off with the questions that we were having in the discussion about why does Wireshark do this? And so I grabbed a couple of other things as well and merged them together. And the idea is let's get some answers on these things. So that's really what's kicked us off with the AMA. And I'm hoping it's going to grow into something bigger in the community. And obviously, at the end, we're going to have Q&A on what we're talking about today. But I'm also going to open up and say, ask us anything. And I'm hoping that someone's going to ask a question. And the answer is going to be, that is a great question. Let's make that a future AMA session. So that's what I'd like to see happen out of this. Today's schedule, we're going to talk about frame check sequences in Wireshark. Then we're going to talk about the packet length in Wireshark. Then we're going to have Q&A. And then, as I said, we'll have an AMA where people can ask anything. And I don't expect we're going to get through every single AMA question, but we'll make a note of them and make them available in future AMA webinars. And hopefully the goal is to do one of these a month if we can keep on doing this. And I think that will be pretty good. And I've learned something new today from the conversation we were talking, the pre-chat. We are talking about where people are from, and people are saying that they're up beyond the Arctic Circle and near the Arctic Circle. And I just learned that someone said polar bears are huge, and I hope I never find out. I really don't want to meet a polar bear. Unless, of course, it's Santa's polar bear that will be cute and cuddly, of course. Apparently not, right? Okay, I digress. So first of all, let's talk about frame check sequences. And we take frame check sequences for granted, but there are a lot of there are a lot of tricks and traps in Wireshark when it comes to frame check sequences. So first of all, frame check sequences are turned off. And this was done in Wireshark 3.0 because a lot of Ethernet network interface cards would offload the frame check sequence, and Wireshark would report errors when there actually weren't any. So because the NICs offloaded, Wireshark just turned it off. And so by default, you may find that Wireshark is not calculating frame check sequences. So it will show as unverified. Okay, nice and simple. Now, if you go into Wireshark preferences and go into protocols, okay, and then you go into IEEE 802.11, there are two options there. The first option, assume packets have a frame check sequence and validate the frame check sequence checksum if possible. Okay, so there are two options that control what happens in Wireshark with frame check sequences. And you can actually go into advanced Wireshark preferences and go into advanced. And if you search for wireless LAN or WLAN here, okay, it really speeds this up because there's a lot of parameters here. You will see two parameters, WLAN check checksum and WLAN check FCS. Now, obviously, be nice to know which is which. Okay, so an easy way to remember this is what the advanced value that's got checksum in it is the same as the checkbox that has checksum in it. It's easy to remember, right? And so people will now notice that, yes, as always in life, they have swapped the order that they appear in the checkbox options from the advanced options. They are the opposite way around, which is really not helpful, but it is the way it is. Now, I've taken the opportunity to create some profiles in Wireshark, and I've called the profiles quite simply assume FCS and validate. Okay, so in this first profile, assume packets have frame check sequence is unchecked, so no, it's not checked, and validate the frame check sequence, if possible, is not checked. And then if you go into the advanced settings, you can see they are both unchecked. Okay. Then I've got a profile that says assume frame check sequence, yes, but validate, no. And you can clearly see if you go into the advanced section that check FCS is now changed from default and it is now true, which means it's checked. And I did the same for the other way around. I said validate the frame check sequence, checksum if possible. And so that's the profile that says assume FCS no, validate yes. And then you see that one then, the wireless LAN check checksum value is changed and it's true. And of course, last, so we don't leave anything out, I checked both of them, and that's the yes, yes profile. And you can see that they are both changed from the default and they are both set to true. Fantastic. You might be like, Phil, this is a bit boring, but this is laying the groundwork because I want to show you what comes next is very, very interesting. I think so anyway. So there are 8 flags and they are shown in this order in Wireshark for each frame. Okay. The flags are, well, actually, remember, they may, depending on whether you're using Wireshark or Savius or whatever, they may be shown in a different order. And let's not get too hung up on this, but in in Wi-Fi, like in Ethernet, we transmit the bytes in order they appear in the frame. But the bits, when you transmit a single byte, it is transmitted in the opposite direction. Okay? So don't get hung up on the order they are shown. I thought order was the rightmost bit. Don't get hung up on that. Just get over it and understand there are 8 bits. Okay? And they are order, protected, more data, power management, retry, more fragments, from DS and to DS. And that's the order they are shown in Wireshark. So there's all 8 bits, but there are 9 flags. So what's the C option then? Well, everybody thinks it's easy. That means the frame passed the CRC, passed the frame check sequence. Of course, it's not as easy as that. Okay? And this is one of the most misunderstood options and parameters in Wireshark. So here's an old capture, and there is no C. And here's a newer, more up-to-date capture, and you see the C at the end. Pardon that pun, it was not pre-planned. All right. Be aware there are different formats of capture files, okay? And the name of the capture file has nothing to do with anything. So I may name a file .pcap or .cap, and it may be a pcap format or it may be a pcap ng format. Pcap ng is a newer format that's a lot more advanced. So don't get hung up on what the name of the file is. Quite often I load a file and it's called .pcap, and it actually has a lot more information than pcap actually had. So what does the C actually mean? Let's get down to talking about this. What does the C actually mean? So the C means the frame did not fail in Wireshark. Now, this is quite spectacular because the frame not failing is not the same as the frame passing. And that may sound unusual to you, but that's exactly what happens. Okay? Now, it may be because you didn't capture the entire frame, or it may be because you have validate frame check sequence unchecked. Okay? And this now is going to be very interesting. And what I want to do now is I want to take a look. I want to take a look at some frame captures and show you what the visualizations actually look like. And remember, the radio tap header and the frame check sequence pass or fail can actually differ. You may find that the C is present, but it may be an invalid frame. And what I'm hoping to prove to you is the only real way to know the truth about this is to capture the entire frame and then let Wireshark validate the frame check sequence. Now, that, of course, will increase your data capture size. But if you are going to not capture the entire frame, please be aware, as I will show you now in the demonstration, that you may have misleading information. All right? So let's do this then. So first of all, I want to show, let's show an old file that's been around for a long time. It's given out on a lot of the CWNA and the CWNP classes, and it's called akm.pcap. And as you can see, there is no C, again, excuse the pun, there is no C at the end. Okay. So there is no frame check sequence. If you look at the beacon frame, you'll see the information on the beacon frame, and that is highlighted down here on the bottom. So this is the actual frame header. If you then select wireless management, that is the payload of the frame. Now, it's very important, I want to show you that there are no frame check sequence captured in this capture. Let me show you as a variation another capture that I took. And this is a capture that if you've ever been on one of my classes, you'll be very familiar with. I just took a capture one day and I've used it for so long, it's just amazing. It has everything that we need to talk about in like a CWAP class. And the first thing you'll see, let's go for a beacon frame. Okay, actually, no, let's not go for a beacon frame. Let's go for that little quaz data frame would be quite nice. And I'm manipulating this now because I want to show something to you. And so you see, first of all, you see the radio tap header. And if you select the radio tap header in Wireshark, down here, the radio tap header bytes in the capture file are highlighted. And then if I select the quaz data, you see the quaz data frame header, the wireless frame header. So again, the radio tap header, the frame header. And then you see the data payload of this quaz data frame. And what you'll see are 4 little bytes on the bottom that are unhighlighted. And they are quite simply the frame check sequence. Now, the frame check sequence doesn't appear after the frame. Wireshark does this. It's a little confusing initially, but you get used to it. Wireshark puts them at the bottom. So there's the frame header, there's the payload, and there's the frame check sequence. Wireshark puts them at the bottom of the data frame header. So you can see them by going frame header, payload, frame check sequence. Okay? And as you can see, the frame check sequence by default is unverified. Okay? And this is where it really starts to get interesting. So you have the C flag shown, which is it passes the CRC, everybody assumes. But we aren't actually looking at any manipulation of frame check sequence. So first of all, let's go in and let's say assume frame check sequence, yes. Validated, yes. And now you can see that we have frames. And this color here, by the way, this color usually means some kind of frame check sequence error. Okay, so that frame doesn't have the C. And it says here, look, the frame check sequence is incorrect. It says what it should be and what it is. Now, if I quickly go and look at the coloring rules, you'll see there are 2 rules to pay attention to. And watch out for this. The first one is it's a bad TCP, and the second one is a checksum error. But if you click on checksum error, you'll see that it's Ethernet frame check sequence is bad, IP checksum status is bad, TCP, UDP, and so on and on and on. And finally, you get Wi-Fi frame check sequence is bad. Okay? And so that color scheme you see there, that pink on black, means that something failed, and quite often it can be that the frame check sequence of Wi-Fi failed. But watch this. What if I go and change the profile to not validate the checksum? Frame number 39, you know, is bad. It says there, look, frame number 39. Frame check sequence is incorrect and it doesn't have a C. But watch what happens if I tell Wireshark to not turn on frame check sequence validation. Now, frame 39 doesn't match the coloring rule, because the coloring rule says where the wireless LAN frame check sequence is bad. Now, because we're not checking frame check sequences, now it shows us unverified. So it doesn't match the requirement of the coloring rule, and it doesn't show up as a color. Also, it has the C. C is there. So, hang on a second. That means that it passed the CRC. No, it means it didn't fail it. Is everybody starting to understand? Very interesting, right? Now, you may notice as well that there may be a radio tap header, and there is a flag in the radio tap header that says bad frame check sequence. Even though we know frame 39 is failing the frame check sequence, bad frame check sequence still shows up as false in the radio tab header. Now, as another little side, what if I go back to open AKM? If I try and open AKM where it doesn't have frame check sequences, if I say assume frame check sequence yes, validate yes, now Wireshark marks everything as a failure because we've said assume frame check sequence yes, validate it. So all frames are now failing, well, most of them, because of what we chose. But if we chose in this instance, assume frame check sequence no, validate if possible, then they all become uncolored again. So it's very important understanding what these two flags can do. And by the way, just as a matter of interest, let's take a little look. What if you open a newer, up-to-date frame? This is a Wi-Fi 7 frame capture. So excuse me, a Wi-Fi 7 frame capture that I captured recently. And you'll see that the radio tab header will actually show true and bad, and it will reflect this correctly. If I turn on a packet capture that says whatever wireless LAN FCS status is bad, and I've turned on that I would like you to validate, please. Okay. Now what we see is we get a ton of frames, and these frames actually do have bad frame check sequence true in the radio tab header. Cool, right? Now, one other little quirk that you need to be very aware of when calculating frame check sequences is, let's go back to our old friend Mega. And I'm going to sort the frames into length, okay? Because I want to show you something. As you scoot down here, everything looks really good. And when you get down to about here, there's a data frame, okay? There's an old frame, look, an old frame check sequence. It is correct. There it is. There's a frame check sequence. Everything's looking good. What you'll notice, though, is as we go a little bit longer, let's get a frame size of around about 120. 116 will do. When you get to the end of this line, that's 128 bytes. Okay. And so I'm looking at these. Okay. And I'm seeing that we have 120. You can see it's getting closer and closer. And then we seem to have a lot of frames here. Let me just zip down a little bit. Okay, still going. And now we have 126. Yeah, nice and simple. And there's the correct CRC. Now, the point I'm trying to show you here is, there's 128. There's the CRC. But look what happens when we go to 130, 131 bytes. It doesn't get any longer. Where's the CRC gone? There is no CRC calculation anymore because the option we said is validate CRC if possible. Well, when I captured this capture, I only captured the first 128 bytes. But we know it's a valid frame, right? Because it's got the C. Well, do we? I'm pretty sure that this 4,121 byte behemoth down here isn't actually an acknowledgement frame. So it's obviously some kind of corrupted frame, but look, it's got the C. So you cannot assume that C means it's a valid CRC. So a lot of these frames are probably corrupted, but because I only captured the first 128 bytes, we didn't capture the rest of the data, and we may not even capture the whole header. We definitely didn't capture the frame check sequence. And so that's why I mentioned earlier, one of the best things you can do is you can always capture everything. And you can see now that this probe request look is quite huge. But sitting right at the end, where we expect it, is the last 4 bytes of the frame check sequence. So I would suggest you always capture all data, and you then let Wireshark choose whether to let Wireshark calculate whether the frame check sequence is correct or not. And then you can know that the frame check sequence is correct, or you can know that it's bad. Don't just rely on this C value in Wireshark. Cool? I want to talk about the next subject now for a few minutes. And the next subject is a nice, easy one. It's packet length. Okay? And hold on a second. Frames and packets. An extra bonus I want to talk about is one of the most important things to understand about Wireshark is the entire industry blatantly flips between frame and packet. Technically, that is a wireless frame. Okay? It may be carrying, if we find like a data packet. See, I said the word. It may be a data frame. It may be carrying some data, which may be an IP packet. But throughout the entire industry, we will always talk about frames and packets correctly, and we'll correct each other, except inside Wireshark. Inside Wireshark, the words frame and packet are interchanged. So we'd say that that's a beacon, that's a wireless packet. Well, technically, it doesn't contain any layer 3 data, so it's a wireless frame. But please understand, in many texts, rightly or wrongly, you'll see the word frame and packet interchanged. So you might see that this is explained as the packet pane. This lists the frames, but this is the packet pane. But don't get hung up on that, okay? It's another thing we have to get over. And by the way, whenever I create a presentation, I always give it to our graphics team, and they thought that showing you a frame within a frame was quite funny. And I actually thought that was really cool, okay? So is it a frame or a packet? Well, it's a frame, because you can see it's like a window frame. I just thought that was funny. And then I wanted to talk about the layout, and we kind of hinted it already. Inside some of the older captures, you may come across an old capture, like AKM, and it's just simply got frame, and frame is Wireshark telling you stuff. And then, of course, it goes straight into the actual frame and the payload. Well, looking at a more recent capture, and I'll just stick with my Wi-Fi 7 capture because it's useful. Frame, and what it does, it highlights the entire everything down here. I don't turn this off. Quite often I'll drop it down as low as possible to get some more real estate, but sometimes it's quite useful. So frame is information about the entire entity within the PCAP file. The radio tap header is an actual series of bytes in the PCAP, and 802.11 is again Wireshark giving us information. So frame and radio information are Wireshark trying to help us. Radio tap is directly out of the capture, and there's the frame, there's the payload, and don't forget the hidden 4 at the end, okay? Don't forget them. They will appear under the IEEE 802.11 frame. And so that will be whatever type of frame it is. And so the FCS is shown there, the last 4 bytes down here. And so that's the actual layout of what we see in Wireshark. Now, packet length, okay? Packet length is not correct in Wireshark, because you all know that an acknowledgement frame, right? Acknowledgement frame is course, now I can't find one. An easy way to do this, I always alphabetize the information field. Oh, okay, here's another error you got with Wireshark. Basically, what Wireshark is saying is, hey, we haven't got enough RAM to do what you want to do. So you've got to go into a layout, if I remember correctly. And again, be careful doing this. If you get carried away, you may crash Wireshark, but I just simply add a couple of zeros there. And that's usually enough. And now what he was saying before was we haven't got enough RAM to do the sort. So now if I click on info, now I've allocated a bit more RAM. And again, be careful doing that. Now it's in alphabetic order. So now I just scoot up and I find an acknowledgement frame. And then once I found what I'm looking for, I always click on the number column to put it back in numeric order. To put it back in numeric order. And now you can see that we all know that acknowledgement frames are 70 bytes. No, acknowledgement frames are 14 bytes. So what Wireshark is actually doing is it's counting the number of bytes in the PCAP. So 70 bytes on the wire. No, 14 bytes were transmitted because acknowledgement frames are 14 bytes. So how do you find the real size of frames in Wireshark? Well, actually, it's quite simple. I took the liberty of creating a profile, and the profile is called radio tap length. And what I did was I expanded the radio tap header, and there is the header length shown there. And so I right-clicked that, and I said apply as a column. So now you can see that the length of this frame inside the PCAP file is 70 bytes. But you know that 56 of those bytes are the radio tap header. And that leaves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is the actual size of the acknowledgement frame. Wait for it, with 4 bytes of the frame check sequence at the end. Now, again, I've left this as do not check frame check sequence. So it's actually shown as unverified. But by showing the header length, and that is the radio tap header length, you can see that length minus radio tap header length will give you the actual frame size that was transmitted across the air, which of course, in this case, is 14 bytes. Now watch out for this. The header length is not always the same. The header length depends on what tool you use to capture the frames and whether it's a 5 gigahertz, 6 gigahertz, N, AC, AX, BE, Wi-Fi 4, 5, 6, 7. It depends on which type of packets or frames you are capturing and what the capture device is. So for example, here's one capturing device, and this was a Sidekick 2, my Sidekick 2. I also have another one to hand. This was used by my WLAN Pi, my wireless LAN Pi with the twin Intel Bs, the wireless LAN Pi Pro. And as you can see, that one does a 48-byte header length. So there's different attributes that different capturing entities will capture. Okay, so be aware that the number can change. So as a summary, okay, I don't think the packets lie. I really don't think they do. Packets never lie is 100% true, but our understanding and our interpretation of them may mislead us down the wrong path. So we need to make sure we understand our tools and know what they are telling us. So that brings us to the end of the first session. We're not over yet, but not by a long way. So the next webinar in a month, we're hoping to have this one called Certificates Help Please. And this is going to be led by our associate Tor, who's quite a guru on all things security. We'll announce this a little bit later. Hopefully, we're going to do it early February, but we haven't finalized the date yet. Just to mention, if you do want to become an absolute guru in Wi-Fi, you got to do some study. And we have a CWAP class coming up, which now includes the latest Wi-Fi 7, WPA3, exam voucher, and practice tests. That's actually coming up next week. And then there's some other courses coming up later on in the year. I want to mention here that NC Expert, our consultancy team, will come and help you if you have a problem or a design issue or a design you want done. And there's, again, a review of my contacts. And that's us done. Now, I want to open for Q&A on what we've talked about at the moment. Yeah, so German is saying, right, an RTS is a standard 20 bytes, CTS is 14 bytes. So by looking at, you can look at what those values are, load up the packet, the radar tab header, and you can either just remember these or just open the radar tab header and look. But if you know the acknowledgement is 14 bytes and it's showing 70, you know there's 56 bytes of overhead.
Also, German earlier made a comment/question, and he said, I work a lot with managing profiles and display filters, but I struggle to show my display filters that were made in one profile in another profile. Keith suggested that he copy it using a text editor. Are you cool with that? Does that make sense to you, Phil?
Yes, I understand what's been said. So profiles, as Keith said, what I tend to do, bear with me a second. It's telling me I need to turn up my volume. Okay. What I like to do, and again, I'm in Apple environment. It's different in Apple and in Windows. But if you go to Wireshark, about Wireshark, and if you go to folders up here, okay, it shows you all the folders. And if you dig around like personal configuration, if you click on that one, it actually brings up that folder. Now, it's a bit brave to go in and start editing things, but you can export and import profiles. And so, yeah, I've got to be honest, I've imported and exported a lot, Keith, but I've never tried to export and import and edit the profiles. So you can see, look here, basically what's happening is this one says, let's click this one. And if you go and look at it, I believe if we open with like a text edit, if I remember, yeah, it's quite simple and well documented and well explained. And so technically, once you find what it is you're looking for, you can go and edit the value and then just edit it in the profile. And you could probably do this with a Python script, or you could just manually search for it. So if I search, for example, for wlan.fcs, my glasses on for this one. Actually, what it was wlan.check FCS, wasn't it? I think it might have been underscore. There you go. So there you go. WLAN check FCS, WLAN check. So it's grayed out because nothing happened with it. But the one that I changed to true look is changed to true. So technically, as Jermund and Keith were saying, if I wanted to share a profile with you, technically I could go in and I could just make this change, uncheck the pound sign, okay, which I'm not going to do. And I could change that. You got to uncheck the pound sign, otherwise the pound sign is like, it's a comment. And I could change the value. So yes, a very easy way, well, relatively easy way to go in and edit the profile settings with some kind of text editor. Just make sure Uh, Apple tends not to do this, but Microsoft, if you use like Notepad, if you save as, it may save it as a dot text, which means that Wireshark will no longer read it. It has to just simply be called preferences, not preferences.txt. Okay. And so you can do a get info in Apple, and you can see that it is, in fact, yes, it's a text file, sure, document, but it's not dot text. Okay. And just watch out for that. Because if you add a dot something at the end, then Wireshark will not see it as what it wanted to see it as. Yeah, German. Yeah, go for it. Do a video. And I know German does a lot of videos in the community. And so, yeah, absolutely. Absolutely. What else we see here?
The German's also talking about, he said it's the challenge is not the profile, but the different display filters that he wants to be shown in all profiles. Would he be able to copy and paste it in from one profile to another, the display filter portion?
So you mean, so there, for example, there's all the display filters that I've used. Now you can, so what profile am I using at the moment? I'm using a radio tap length. So you can add a filter, add a filter that will appear as a button. So there's the filters I've used in the radio tap length. If I now change to a different one, you can see that they are still there. So they're the same. So they are not stored per profile. So radio tap flags bad CS equals true. What if I change to a different profile? Yeah. So these will be display filters. I may have to go and look for this. I may have to take this offline, but they are display filters. And I'm going to go and look at where they are. So there will be display filters, but I do not remember where they are stored.
Okay. Keith has just suggested that the file is actually called defilter underscore buttons.
Of course, that's for the buttons, but and defilters should be the other one, shouldn't it? Yes, defilters.
Phil, I don't know if you can hear me, but if you created
Yes.
like a sample display filter, it should create that file in one of those profiles, and then you'd be able to see it.
Oh, good call. So you actually want me to create a button, right?
Yeah, yeah. Create a display filter in one of those profiles, and then that file should be created for you so you can see it.
So if I take this, if I take this one, for example, and just copy it, and just simply call it bad FCS, very unimaginative. There it is there, brilliant. And if I now say okay, now we have that. And so now, do you think under radio tap length?
Yeah. So if you expand that folder, it should be a file now. Yep, there it is.
But the default buttons only
They're all considered, I guess, buttons in that sense. You can create them in menus if you use like the forward slashes, but they're all kind of considered buttons in that area.
yeah, but I think the button is under the radio tap because if I change the radio tap, if I change the filter, the button disappears. And so that the buttons are per profile, right?
Yes, per profile. And I think that's what Drummond is trying to do is copy those buttons from one profile to another easily.
Yes,
Yeah,
I think
I'm under on the left, up in the left where you can manage display filters. And there the filters will not follow from one profile to another.
but I
If you
think
go up to the left on the blue small down up there is a manage.
yes, yes.
Yeah.
So yes, now this I believe is stored as D filters. So I believe that's stored as D filters, and just simply that will be stored in, not in personal configuration, but in hold on a
The global configuration possibly a little bit above.
So it's I always look for this. It's the second. It's not that ethers. It's the second ethers, which I think is in. I think it's preferences, profiles. I think maybe it's that one.
Yeah, I have to look for it, and because I try to make the 7 or 8 different profiles to show different things. And in each profile, I need the same display filters.
Okay, yeah, we can talk offline as well. And if you do it, don't forget, please write a blog on it so we can know. And I think, if I'm not mistaken, that it's there. It's in that file called D filters. But it is an unusual format, right? It just seems to be the filters. Okay, no, it is just the filters. They go, yes. So the D filters, these, I think, if I'm not mistaken, these are the filters that you can see there. But you have to go and look. You have to go and look. There you go. Look, yeah. See,
Yeah.
so these filters are listed there, and you find that in D filters. Thank you, Keith. When you said D filters in the personal profile, it reminded me. So yes, and you find that by going into Wireshark. This is awesome, guys, because it's like helping each other, and we're all learning more about this stuff. So if you go to About Wireshark, as said, it was the global configuration that stores the global configuration, and it's the personal configuration that stores your personal profiles. Epic stuff. Okay. I'm seeing it coming up to time. Are there any more questions about what we did today? Brad asked when I said the FCS was offloaded. So the frame check sequence was offloaded from the capturing entity to the hardware. So the hardware NIC would automatically capture the frame check sequence or calculate the frame check sequence. So when we say offloaded, when the frames were transmitted and received, it was no longer calculation and validation of the frame check sequence was no longer done in software. It was done by the Ethernet NIC card. It was the NIC itself. I only collected 128 bytes of data, Brad, because I was being a smarty pants. I thought I don't want to have all that data. What a lot of people miss is if I capture data on a network, a Wi-Fi network, on an SSID Wi-Fi network, and assume I don't miss any packets or frames. If somebody is watching a Netflix movie, or if somebody is making an audio call, there are tools available that can extract that data from Wireshark. So technically, ignoring encryption, you could watch a movie. I could watch the movie that you downloaded because I've captured all the packets. I can replay your audio call. Okay. And so if somebody is downloading a Netflix movie while I'm capturing data, and that's a 4 gigabyte movie, I'm going to capture that 4 gigabytes that was transferred over Wi-Fi. So my capture file is going to be quite huge. So a lot of people don't capture the entire frame. They restrict the frame size. So they don't fill up the hard disks, basically. And different capturing tools will do this differently. I know Adrian Granadis' tool, it gives you the option to not capture the MSDU. So you can capture the entire frame and the frame check sequence, but you don't capture the payload frame. The problem is if you do that, you cannot validate in Wireshark. If Wireshark doesn't see the whole frame, Wireshark cannot validate if the frame is passed or failed the frame check sequence. Okay, I don't see any more questions. So let's move on to the last part then, which is, this is where we come to the AMA, the last 10 minutes. Feel free to shout out any questions about anything, and let's see if we can get some more subjects for some future chats. Give everybody a few minutes. You are more than welcome to ask a question about what we talked about today, or just a general question about, hey, Phil, one thing I need more information on is this, and we'll see if we can find somebody that knows about this and tell you all about it.
I have one I think I'd like to ask on audio. You were talking before about the different size headers that we might see based on the capture tool that we use and the like the protocol version, whether it's going to be 802.11be or AX or N or AC, whatever. And my understanding is that's going to be because there's going to be additional header information in the newer generation packets, reflective of the updates to the protocol. Do you see that as a driver to get current radio technology out there for all of your, devices? Are we going to have to constantly be cycling gear, on a 3-year basis moving forward as we're making more and more complex, uh, uh, you know, protocol information available to use when we look at things like MLO and OFDMA and et cetera, et cetera?
That is a great question, and I'm afraid I'm going to have to answer it depends. And I'm not the first person to say it, and I won't be the last, but I do believe that Wi-Fi analysis is going to change and move away from capture with a tool to capturing from the infrastructure. Cisco, Meraki, Mist, Ubiquiti will now all let you capture traffic from the AP, from the management interface, the cloud or the wireless LAN controller. And recently I did a capture with Meraki and Cisco, and I was very impressed because not only did it capture traffic that was going to and from the AP that I told it to capture, it also captured other traffic that was passing on the air as well, which was very interesting. Because I don't just want to see my packets being captured, I still want to see what's going over the air. And now one way to do that is to turn an AP into a capture device. But the problem is, what a lot of people do is they'll buy Cisco's new 9167 APs. What do we do with all the 9166s? Well, why don't we turn them into capture APs that we spread around the building? But they don't understand Wi-Fi 7, right?
Yeah, they can't decode the frames. So
they can decode the management and the control frames. They just can't decode any clever Wi-Fi 7 stuff. So you may miss.
And part of that also then is going to be like, well, the PMF and WPA3, right? So we can't decode that like we can with the WPA2. So we're not going to be able to unencrypt or read any of the information anyway, right?
Well, within limits, because contrary to what people think, management and control frames run at G and A speeds, even in Wi-Fi 6. In Wi-Fi 6,
they have to, right? Yeah.
Run at G and A speeds, which is ironic because G and A don't exist in Wi-Fi 6. But most management and control frames run at standard OFDM G or A speeds, 6, 12, 18, sorry, 6, 9, 12, 18, 24, 36, 48. Okay, 54. They run at those speeds.
Your lowest mandatory
yes.
set, right? Yeah.
Well, beacons run at lowest mandatory. Management frames tend to run at lowest mandatory. Control frames have a different set of rules. They can run at any of the mandatory speeds. And so technically, management and control frames can use A, mandatory basic, B, minimum mandatory basic, or they can use any of the other speeds. But most of them most management frames tend to go at the lowest configured mandatory basic. But control frames, I was always of the belief that they run, like acknowledgement frames run at the next speed equal or below what you transmit at. So whether you transmit at 48 megabits or you transmit at 867 megabits, if you got 6, 12, and 24 as your mandatory basic. And I call them mandatory basic because everybody in the industry calls them basic, except for Cisco, that calls them mandatory. So I just call them mandatory basic when everybody's happy. So the acknowledgements will still come back at mandatory basic rates. But of course, block acknowledgements can be transmitted at much higher rates. And so there's still a little bit out there where you can see some of the management and control frames, but what you won't see, of course, is the data frames, which you may want to pay attention to, especially if they're running at 160 megahertz and your AP only supports 80 megahertz or some such thing. So yes, absolutely. Keith has raised a really good point. Curtis said capture from the infrastructure would also help, and Keith said when it works. And that is a very good point. It's not as perfect as I would like it to be. Absolutely right. It doesn't capture all the traffic. Yes, that is absolutely correct. It does miss some traffic. So it actually, you're right, it even misses traffic that the AP sent and the AP received. Yes, that is true. Yeah. All right. Any other questions, guys?
German raised Wi-Fi calling, but we're at the top of the hour now, so I think we're going to have to leave that to a future webinar.
That would be a great one to have in a future webinar. The impact of Wi-Fi calling, which of course is when you turn Wi-Fi calling on, it's trying to make your cellular phone operate over Wi-Fi instead of necessarily operating over cellular. And now you've opened a whole can of worms because now you need to have nice, clear roaming between. So, saved by the bell, right?
Just about.
There's a little bit of work we got to do talking about that one, but that would be
Yeah.
let's add that to the list of let's talk about Wi-Fi calling in a future.
Sounds good.
Yes, but I think with Wi-Fi calling, it's not Wi-Fi is the main challenge. It's all the gateway that encrypted channel have to go through to its provider.
Yeah, there's a lot embedded. So it's let's just leave it at it's not as simple as turning on Wi-Fi calling. There's a lot of baggage that comes with it, I think we'll say. Oh, now you're talking this. Open roaming, hotspot 2, and cellular offload. Sebastian's got a good one. 10 difficult to identify Wi-Fi issues and how they were resolved. Okay, yeah.
Everybody's coming up with all these great ideas now.
Fantastic.
This is good. I like it.
Let me get a screenshot so I can make sure we've got these.
Cool.
All right,
Yeah. Thank you, Phil. Really appreciate it. And thank you, everybody, for joining us. And hopefully you've enjoyed this session. And, when we do the next one, we're looking in maybe a month's time. Obviously, there's the WLPC conference coming up next month. So that's going to impact when we can actually do it. But we will keep you guys informed as to when we'll be able to get the next one underway. What we're going to do is edit this video and then put it onto our YouTube channel, and then we'll email all of you people who've attended today just to let you know where it is. We'll send you the link so that you can watch it again, and then maybe you might come up with another idea of a future webinar, and then we can add that to the list as well. So that's great. Well, thank you very much, everybody, for attending. And thank you, Phil, for your expounding your knowledge to us.
Thank you, everybody.
So that's great. And we'll see you next time. Thanks, everyone.
See you next time.